Here's problem number 35 from 39 from the chapter review. Let's do our automatic rewrite of this problem. The limit as a approaches negative infinity of the integral from a to negative 1 of 3 dx over 3x minus x squared. Now we're going to look at this and we say this looks like a partial fraction decomposition problem. So let me do a little side work here. If 3 over 3x minus x squared is equal to 3 times, and let's factor out that x, 3 minus x, and therefore we can be rewriting it as a over x plus b over 3 minus x. If that's the case, that means 3 is equal to a times 3 minus x plus b times x. If we let x equal 3, we get 3 is equal to, the a goes away, and I end up with 3b, or b is equal to 1. If I let x equals 0, I get 3 is equal to a times 3 minus 0, which is 3 is equal to 3a. A is equal to 1. Or in other words, this can be rewritten as 1 over x plus 1 over 3 minus x. Bringing that answer back over here, our rewrite then becomes the limit as a approaches negative infinity of integral from a to negative 1 of 1 over x plus 1 over 3 minus x dx. The antiderivative of 1 over x is natural log absolute x. The antiderivative of this is going to be the natural log of 3 minus x, but because of the negative sign here and because of the u substitution that would be necessary, we get a negative sign there. And if that's the case, then it's being evaluated from a to negative 1. So let's evaluate it on those bounds. And we get the natural log of absolute of negative 1 minus the natural log of absolute 3 minus a minus 1 minus the natural log of absolute a minus the natural log of absolute 3 minus a. A couple of things going on here. It's an absolute value sign. First of all, absolute value of negative 1 is 1, natural log of 1 is 0, so that goes away, leaving us here negative natural log of 4. Now over here I've got a minus, and I can rewrite this as the natural log of absolute a over absolute 3 minus a. Now what happens here when a approaches negative infinity? Well, absolute a over absolute 3 minus a essentially becomes a big old 1, and the natural log of 1 ends up being 0. So when I apply the limit, this whole term goes away, leaving me nothing but the negative of the natural log of 4, which the answer key decides to describe as 2 times the natural log of 2. If I can take that 2 up there, I get a 4, and that's the answer.